Hello everyone. So in this video, we will actually review past question paper across last couple of years, um, and we'll actually try and cover topics from classification, unsupervised and k-means, uh, and as well as in terms of classification, can and decision tree and cross validation, which are the major topics. So let's look at this first question. So while going through this, I might be scrolling it if I see that questions are not correctly categorized. But these are the questions from your actual past paper, right? So you can look at 23, 22 supplementary. These questions are taken from there. I'll also put them as a resource, in this playlist, so that if you don't have access to them, you can just take it from there. So every and then there is a no, there is actually missing information represents the outcome of test in a decision tree. So which one? Leaf node, right? So all your decision points are where? They are at leaf node. You might be remembering from your decision tree examples that we took, right? Z score, so we actually saw it, right? Z score is a measure of how many uh, sort of a standard deviation away from an element the mean is, right? So, but this is actually covered anyway. Ethical consideration. Let's review it. What are the ethical considerations related to data accuracy? So, inside data is accurate and reliable, complete and consistent, relevant and timely. All of the above, right? Let's look at the next question. The algorithm is one of the most basic and easy to implement supervised machine learning algorithm, right? K nearest neighbor, right? We actually talked about it, right? Why not decision tree? Well, decision tree is more complex than K nearest neighbor. Classification and scoping are general terms. The what term you describe regression method that have a linear function relationship between dependent and independent. Linear regression models. You can review these ethics related things separately. Okay. So what is the square root of variance of the residual score, right? So we are talking about root mean square error here. Algorithm is one of the most basic and easy to implement. Canyon, we saw this. Decision tree are used to solve only classification, only regression, till it is both classification as well as regression, right? KNN stands for what? So you'll be asked for it. Knowledgeable neural network? No. K means nearest neighbors? No. K nearest neighbors. Caroli neural network. So try and make yourself familiar. This question is, I think, asked many times. What term is to describe regression methods that have a linear function relation? Linear regression methods, right? We have reviewed this in past. We'll not go through them. Data privacy, others. Okay. So differentiate between regression tree and classification tree. Also provide a level diagram of a simple decision tree, right? So regression tree again will be used when your outcome is continuous, right? Say for example housing price. So in that case, you can use a variation of decision tree that can help you do that. And if it is categorical variable, then you use classification tree. You can use this example for decision tree, right? So this is from your iris dataset, and we are showing that if you use petal width, then when it is less than this or greater than this, right? Across these samples, you find out the Gini, and you can take the rest of the things from there. So about K means, right, and how it works. We have seen this, right? Initialize the centroids, then make membership, then you update the centroid and repeat it unless it is stabilizing, right? What is the principle on which KNN works? So lazy learning, that's one, and the second one is it doesn't make any assumption about distribution of data, so non-parametric, right? So this is those are the two things that we have to list. Any four disadvantages, right? Lot of them. So computational class complexity could be higher because of once your variables increase. Sensitivity to noise, so outliers, actually it will be very difficult to model. High dimensional data, hard to manage. Lack of interpretability, so KNN is actually not easy to interpret, as we have seen in case of DecisionTre. Yeah, so same disadvantage. What is cross validation? What is its use in data science? So cross validation is when you divide all your data set in multiple groups, and then say five so k fold cross validation, right? So 5-fold cross validation is you divide equally your data set in 5-fold, and then use one of the fold for testing and 4 for training, and then repeat. So in case of next, take the another one. So in case of step one, if first was used for test, in the second step use second for test, another for train, third and fourth and fifth similar way. It helps you reduce your bias, and it is also kind of used to find best value for your hyperparameter. So in case of k means, right, what is the value of k? In case of k, what is the value of k? Those kind of things. Linear regression, we have seen multiple linear regression, we have seen in previous video. Explain any 4 real world application of unsupervised. We have seen this: customer segmentation, early detection, image compression, and news. There are many others, right? We have seen it multiple times. Cross validation, when to use linear regression, define. We have seen all of these, right? We actually covered it while covering, right? Difference between regression and classification trees. Level diagram, okay. Uses, we are repeating it again. PDA, other things we have seen it. So that's it, right? So that actually kind of covers most of the questions that we have seen. We have been actually. Now, what we'll do from here on, we'll actually just have 1 or 2 more videos on this topic. Where in one video we'll actually sort of analyze your mini project, and in the second one there is a recommended major project. So we'll use actually a notebook and show you step by step how you can actually do that. Thanks for watching. See you in remaining 2 videos. Do engage, comment, like, subscribe if it helps you.